I'm Phil, and today we're going to look at a third generation Maqueen Plus robot from DFRobot, and they're located in Shanghai in China. So let's have a look at the what this robot is and what it looks like. So the Maqueen Plus version 3 uh, is designed for STEM education, and you use it with the microbit computer. And what's unique about it, it's got a matrix laser ranging sensor with 64 sensors. That's an enormous increase over a single point that you might get with a time of flight sensor. And what's nice also about it, it's got a nice power source using a 18650 battery. It has a line following algorithm built in, and it can recognize intersections. And this is what it looks like. Right on the top, we've got our laser matrix sensor, then the battery component or compartment, and on the bottom we've got our baseboard with the wheels ready to house a microbit. So how much does it cost? Well, the regular price is $69.90 US, and I ordered this fairly recently on the 28th of May, and it arrived this week on the 2nd of June. Applications, well, for STEM education, but a little bit more important, it's for robotic competitions. And it has streamlined algorithms to help you with those competitions. So if we look at the specifications, for line tracking, we've got 5 sensors, and we can calibrate those, and the outputs are both digital and analog. And you can experiment with each of these to see which one works for you. We've got built-in intersection recognition for crossroads, T-shaped intersections, and right turn and left turn. And you've got options on each of these for going ahead or turning. And it's got a built-in algorithm for speed with 5 levels of adjustment. Looking at the matrix laser ranging sensor, we've got 64 points arranged in an 8 by 8. And there are 2 modes. There's the measurement mode and the intelligent obstacle avoidance. And the accuracy on that, over 20 to 200 millimeters, is 11 plus or minus 11 meters. And that goes down a bit, actually, beyond that range. And it's got a detection, a field of view of 60 degrees, both horizontally and vertically. In addition, we've got a sensor for light, and there are 2 of those, one on the left, one on the right. There's an infrared receiver, and the motors have encoders, and there's a PID controlled algorithm in firmware to help you with the speed control and measurements. Okay, so if you want to compare this with a previous version, you can see there's been a fair bit added in terms of sensors and built-in functionality in the firmware. So interesting. I wonder how it goes. We might go across and have a look at what software is available. Well, it's all Makecode, and you have to use the extensions provided by DFRobot. And they look like this. So you get 3 rows, the IR, the matrix LiDAR distance, and the Maqueen Plus version 2 and 3. Okay, it doesn't work on the Microsoft Makecode for robots, which was a bit disappointing. I was hoping it would work, but it didn't. Okay, so the projects I've been working on are mainly the demonstrations from the wiki on the DFRobot. So I've done the line following, and we might just look at one of those. This one here, the objective was to provide a line following program and give the user some feedback. And this is where the LEDs come in handy. You can use that to debug your program. So the Maqueen Plus has got an onboard 5 tracking sensors. And when the black line is detected, you get an output of 1. When it's not detected, you'll get an output of 0. And we can look at the sensitivity of those sensors. So for the hardware for this project, we've got the microbit version 2, and we've got the DF Maqueen Plus version 3. Software-wise, what we're going to do is use the sensors to track a line. And the code for doing that is here. So we might look at the demonstration, but what we're doing is looking at the combination of only 3 of the 5 sensors in different combinations. So we'll have a look at that in the demonstrations later on. And we were able to achieve our results on that. So that went quite well. So another important area was the recognition driving along a Pacific route. And there are 2 of them that I want to have a look at here. This one is interesting because we're going to go along any of the paths that are indicated here. And we might look at the objective. So we're going to use the robot to drive along a Pacific path. So let's have a look at that in a little bit more detail. So these examples come from the DFRobot wiki. And the first one, we're going to look at the intersect recognition. And what happens here is that when we call the intersection detection function, we get a return from the function of 1 to 4, depending on the type of intersection that was detected. And if we run this in Microsoft Makecode, then download it to our microbit, we'll see these numbers as we move our Maqueen version 3 over different types of intersections. And the next example, we're going to go through different intersections, and we'll either do a right or a left turn or go straight ahead. So this is the actual route that we want to follow. And what I've done is to translate that into a graph where you can see on the bottom that we start off on the bottom with a ordinary straight through intersection. We get another straight through intersection, and you can see that it's a fairly interesting route to follow. And if we translate that into code, this is what it looks like on example 3. Okay, so we're trying to generalize that for my own route. So I'm going to use the DFRobot route map, and I'll also use the output from calling the intersection function. So here's my map on the screen, and I'm going to start on the bottom left and move to the top right for my first path. For my second path, I'm going to move to the top left with endpoint B. So this is what the route for path 1 looks like. And there are 2 ways of doing it. The first way is just list the behavior at each of the intersections. So the first intersection after we start from 1, we're going to turn left, which is point 2. Then we're going to, at 3, we drive through at the right turn intersection, and at the crossroad, we drive ahead, and at number 5, we're going to go right, and at the left intersection, we turn left and end up at number 7, our end point. So that's the instructions for our robot. And for path 2, these are the instructions. So you can see this, how many are there? 1, 2, 3, 4, 5, and they correspond to the point, the intersections 2, 3, 4, 5, and 6. Okay, another way of doing path 1 is to use a different program which has a function for each intersection type. So you can see that there are 2 crossroads, and depending on the straight through and the position along the route, we'll use a different behavior for our robot. And this is what the program looks like for that. So the results, it worked on most of the intersection, but it missed out on a couple of the crossroads. So both for path 1 and path 2, there was one problem with crossroads. So it missed out on these ones. So I'm not sure what's happening there. It may be a timing issue. Our software doesn't use a real-time operating system, and yet we're trying to simultaneously do things like move the robot and sense and make a decision on the type of intersection. So I suspect that there's a timing issue, and we might have our intersections too close together. Okay, so we might move on and have a look at a couple of the other projects. The next one is using the infrared remote control, and this particular example here, what we're trying to do is demonstrate how to control the robot to move using the infrared remote control. And we're going to show the direction of movement on the microbit's LED array. So the components of that are the microbit, DFRobot Maqueen Plus V3, and a handheld IR remote controller. And we're going to decode the functions. So on the bottom, there's a cross represented from 2, 5, and 8. And that will give us 2 will give us forward, 8 reverse, 4 is going to give us our turn left, and 6 will be turn right, and 5 will stop. And the software for that looks like that. And we're actually showing on the microbit LED array the turns that we expect for our robot. Okay, so the results of that were satisfactory, and I'll have a demo at the end of navigating our mind map. Okay, a new unique feature is the 8x8 matrix laser sensor. And this is what it looks like. You can use a PID algorithm to detect an obstacle, and you can also go to a specific distance using the PID algorithm. Okay, so the idea here is we're going to use the matrix sensor to find obstacles in front of the robot. And the Maqueen Plus version 3 is equipped with this 8x8 matrix. And this is what it looks like. So depending on which row, if we pick Y0, then we're looking for objects that are fairly high up, whereas Y7 will be objects or obstacles which are lower down. And this is how it works. So we've got a field of view of 60 degrees, both in the horizontal and vertical. And we're ready to demonstrate that. Hardware-wise, we use the sensor, the matrix laser sensor, comes with the version 3 kit. And we're ready to have a look at the software. So stay tuned and we'll have a look at some of the examples of that. And I've also looked at other examples where we look at obstacle obstruction. And here there's a interruptible mode that allows us to stop, then continue along the prescribed path for a fixed distance. Okay, so our last examples will be based on PID algorithms for the speed detection. So the background to that is that the Maqueen integrates, has a magnetic induction encoder, and it uses that for the real-time rotational speed, in addition to a PID algorithm, which is in the firmware of our robot. And our PID algorithm is using a closed loop to calculate that rotational speed. So what can we use it for? Well, we can set a distance of travel or an angle and measure that. And the errors that we get for that PID are plus and minus 2 centimeters and plus or minus 5 degrees. So hardware-wise, we use our microbit and our Maqueen robot. And we've got a couple of examples on that. First example is quite simple. The background to that is that our robot is going to work in the non-interruptible mode, and we can't terminate halfway through when we go through that. We execute the program for the set distance, and our program is going to be quite simple. So we might actually have a look at that program now. We'll see it later on. Okay, the other one is a PID in the interruptible mode. And what we're going to do is learn how to use the states of our robot, whether it's a state for being interrupted or not interrupted, and that allows us to continue with our PID algorithm. And we can have a look at the code. This is the alternative code that I've got for that program. Okay, so we might go across to the website. Before that, we'll have a look at the issues that I've got on the programming. I found some of the coding a little bit confusing. Okay, so let's go and have a look at the critique right on the top. We just move up and across, and let's have a look at the good and the bad points. So we'll just increase that so you can see it. So the good points are that the Maqueen Plus version 3 covers more advanced concepts like PID control, and it's pretty easy to use. The downside of that is that it doesn't go into PID control very thoroughly at all. It actually misses out on setting the individual coefficients for proportional, integral, and differential. So it's all done internally and hidden from the user. Another advanced concept is intersection detection and using the matrix laser sensor. So it's actually quite useful in that area. And it also can be extended because it has good access to the microbit ports And there's also plenty of places where you can add additional mechanical gadgets like catches and other sensors if you need to. The software, quite reliable, using the Microsoft Makecode extension. And the way it's constructed, it allows students to build their robot code with minimal instructions. Construction-wise, well built. It has a minimum assembly, and so you can assemble it, say, within about 10 minutes quite easily. Good instructions from DFRobot. And power-wise, you've got a battery indicator that lets you know how much juice is left in your battery, and a good-sized battery. I think one nice thing is the advice that DFRobot gives on electrical safety in handling that battery. And they provide a nice little catch so you don't damage the battery or damage your fingers. Line detection, a good range of sensors, and the documentation in tutorials are quite excellent. Although I must admit there are a few mistakes in the documentation online, and it builds on top of the previous versions and goes further. The bad points, well, the documentation is actually a little bit light on technical detail. So it doesn't tell you too much where the ports and where the APIs, what's inside those. That's missing. And we might get rid of that one. We don't need that one. Technical details. It's not like there's no support on the Arduino IDE. You have to rely totally on the Microsoft Makecode. The PIDs, the details of the algorithm are hidden, and you can't adjust the coefficients. Uncertain if it applies to line tracking. So I'm not sure. PID seems to apply to moving the robot along a certain distance or angle, but when it comes to line tracking, I'm not sure if it also applies PID. They don't say anything about that. Also, some of the examples are inadequate, and I'm sure there are some errors. So, or alternatively, you may have to be careful in the way you construct your robot routes and maps. Okay, so there is Python support, but I haven't tested this out yet. And there's no documentation on how you can use it on other platforms. But I have tested the matrix laser array, and the output is also available on its USB. So a Raspberry Pi could pick that up, and you could use that device on a Raspberry Pi base robot. Okay, so for recommendations, it's okay for some advanced topics, but it's a little bit oversimplified, and it's which is okay for younger students because they can do some interesting things with minimal coding. But it's a bit disappointing that it didn't work on Makecode for robots, and some of the instructions, the detail of the instructions, particularly for the PID and for the matrix sensing, are hidden. Okay, so we might go to the website before we do a desktop demonstration. So you can go to DFRobot, and we'll go across and have a look at that now. Okay, so here's the website, and you've also got fairly good documentation. So if you scroll down, you can see the introduction, and if you want more detail, there's a very good wiki provided, which is here. So we'll go to the product wiki now, and here you are. You've got a very good product wiki. Stay tuned, and we'll do a desktop demonstration. Here we have Maqueen version 3 ready to follow the track and the endpoint is in this maze of intersections, and the desired endpoint is over here. So we'll see how close it gets to that. So when I press button A, it's ready to go. So it didn't quite reach the endpoint, but the each of these endpoints has a T-junction, and the idea is that it will stop and show a red light when it stops. In this demonstration, Maqueen version 3 will navigate along the path until it reaches an obstacle, then it will reverse. So let's turn it on and see what happens. And that's Maqueen using the Matrix 8x8 laser array to detect obstacles. Here we have Maqueen 3, version 3, and it's ready to track two different paths. So the starting position with our Maqueen is here, and the first target is A over here, and our second target is B, and we'll see how it goes. So when we press button B on microbit, we're going to attempt to follow path number 2. And again, it's made a mistake at the crossroad.